Students, good morning. Today we are going to discuss about difference of proportion. So what we discussed in our last class. So last class in testing of hypothesis, we have two types of test. So testing of hypothesis, we have two types of test. One is that test and second one is t-test. So this is for small samples. So this is for large samples. So when n value is greater than 30 means we use that test. So n is greater than means t-test. So last class we discussed three types. So type 1, single mean SD given means, single mean and SD given means, that is type 1. So type 2, what is type 2? So this is difference of means. And type 3 is single proportion. Today we are going to discuss about type 4. So these are all the cases discussed in last class. Now we are going to discuss about the difference of means. Difference of proportions. So this is type 4. Look at the problem. If a sample of 300 units. So 300 is nothing but sample size. So therefore it is automatically z test. Here and look at the n value is greater than 30. So therefore this is z test. So 300 units of a product. 65 units are found to be defective. This is automatically probability case. So out of 300 units, 65 units are defective. And in another sample of 200 units, there were 35 defectives. Here what is your probability? Out of 200, so 35 by 200. So out of 200, 35 are defective items. So that will automatically type 4. So what is your question? Is there any significant difference in the proportion of defective in a sample of 5% level of significance? Now, first we are going to write the given details. So, what is given? So, given two samples given. So, sample 1 and sample 2. So, in sample 1, with the n value, so n1 value is 300. In second sample, what is n2? So n2 value is 200. Next P1 proportion. So out of 300, 65 items are defective. So this is small p1 value. The second sample P2. So out of 200, 35 items are defective. So these are all the details given. Look at the solution. So step 1. First I am going to write the null hypothesis, H naught. So what is H naught? It is given by the notation H naught. There is no significance difference. There is no significance difference between sample 1 and sample 2. This is the statement of null hypothesis. Sample 1 and sample 2. Or else we denote it as P1, small p1 is equal to small p2. Next, alternative hypothesis is given by the notation H1. So, alternative hypothesis H1. This is the opposite of null hypothesis. There is a significance difference between sample 1 and sample 2. Next step 2. We are going to decide the level of significance. So level of significance. Alpha is equal to 5% is given in the problem. Next step 2. Step 3. Test statistic. So what is the formula for difference of proportion? So this is the test, therefore z is equal to small p1 minus small p2 divided by root of p2 into 1 by n1 plus n by n2. So again we have a separate formula for p. So p is nothing but small n1 p1 plus n2 p2 by n1 plus n2. So replace all the values, you will get p value. and from this p value calculate q, which is nothing but 1 minus p. So substitute all the values, you will get z is equal to 1.23. So this is your calculated value. So N1 what is N1? So N1 is 300, N2 value 200, and P1, P2. Replace all the values, you will get the value of 1.23. Next step 4. So step 4 is table value. At 5% level of significance, the corresponding table value is Z alpha 1.96. So it is a two-tailed test. Next step 4, conclusion. So what is your conclusion? Look at the table value 1.96. My capital value is 1.23. So modulus Z is less than Z alpha is 1.23 is less than 1.96. So what is your output? H naught is accepted. Therefore, there is no significant difference between sample 1 and sample 2. See you next class. Thank you, students.